Good morning, fifth graders. Hopefully you enjoyed that Bible lesson this morning. Welcome to Math on Wednesday. All right, here we go. We are going to be on page 692. We're going to be in lesson 93. So go ahead and get those math books out if they are not out and open already. And while you're getting those out, I'm going to go ahead and tell you what our objectives for today are. Our main objective is going to be figuring out how to subtract decimal numbers where there's a zero involved, or maybe where there's a zero not involved and we have to add the zero into the decimal number so that we can work it out and get the right answer. So truthfully, pretty easy. I think you guys are going to have this no problem. Cool. If you're not on page 692 yet, go ahead and hit pause, grab your book. If you're there, let's rock. Let's do this thing. So checking it out, the top of page 692, it says, for some subtraction problems, we need to add decimal places to perform the subtraction. If we subtract 0.23 or 23 hundredths from 0.4 or 4 tenths, we find there's an empty place. So if we put that example up here, so we have 0.4 minus point, and let's see, it's 23. Now we have this open spot up here in the top, right? So all we're doing this lesson is putting a zero in there. So we put our zero, now we can borrow to work that out, because I can't take 3 away from 0, right? Nope. So we got to borrow from that 4, it becomes a 3. Put a little 1 there, making that 0 a 10 now, so 10 minus 3, 7, 3 minus 2, 1, and once again that decimal just comes straight down, and that gives us 0.17 or 17 hundredths. All right, that's the whole lesson, y'all. It's like fastest math lesson you guys ever had. So let's do a couple of the examples, and we will rock and roll. So look at example number 1. I think we'll put it over here. Example 1. Now it says, in a test of computing speed, brand X computer completed a task in 0.4 seconds. 0.4. And then it says a brand Y computer completed the task, same task, in 0.2301 seconds. 0.231. Fewer seconds. Now, what length of time did brand Y computer to take the task? All right, let's do this thing. So the whole lesson's what? What are we doing? We're adding those zeros. So let's put our zeros in here. Now we can start to borrow. I can't take 1 away from 0. I can't take 3 away from 0. So let's borrow from that 4. Let's make that 4 a 3. We'll make that guy a 10 right there. Now, let's borrow from that 10, make it a 9, and now we got a 10 right there. Okay, sweet. What's 10 minus 1? You guessed it, 9. All right, and then 3 minus 6. 3 minus 9 is 6. Hey, it's just like class, huh, guys? I do that all the time in class. All right, and then what's 3 minus 2? 1. Awesome. And then we bring that decimal straight down. So the other brand of the computer Y it was, performed the task in 1.69 seconds. Can abbreviate that puppy. We don't need to make the whole thing. All right, sweet. Let's do the same thing on number 2. Example 2 says, a pedometer measures the distance a person has walked. It says Jana has walked 3 kilometers to Rochelle's house. While waiting in a crosswalk, Jana notices that her pedometer reads 1.23 kilometers. What distance does Jana still need to walk to arrive at Rochelle's house? So Rochelle's house is 3 kilometers away, and so far she's walked 1.23. So obviously, what's the lesson about? What do we got to do? We got to add zeros, right? So let's put our decimal point here, throw our zeros up on there, and let's subtract to find out the difference here. Now, I can't take 2 from 0 or 3 from 0, so we got to do what we did over here. What did we do? Someone say it. There we go. We borrowed, right? We borrowed. So that becomes a 2. This will be a 10, but we got to borrow from that 10 also. So that 10 becomes a 9. And then this 0 becomes a 10. Now, easy peasy stuff. This is just subtraction. 10 minus 3, 7. 9 minus 2, also 7. 2 minus 1, 1. So she's got 1.77 kilometers to go till she gets to Rochelle's house. All right, pretty easy, right? Hopefully we're getting thumbs ups like, yeah, it's easy, Mushapu, I get it, yeah. I hope. All right, let me try to get rid of this real quick. Hopefully it doesn't shake too wild and fall off my easel I got holding it up here. All right, it's working good so far. Did I tell you guys I miss you today? Because I miss you guys. I wish we were in room 11 and some of y'all in room 10, but man, I wish we were just doing our normal thing because it's so easy to just teach you guys face to face. All right, so here we go. Example number 3. Maybe I'll put it over here. Example 3. It says, in 2004, the land area of Laredo, Texas was 83.44 square miles. So we got 83.44 square miles. Miles squared. Awesome. Now it says, in 1993, the land area was 44 square miles. So 44 miles squared. Ooh, that got wide. Now, it says, between 1993 and 2004, about how many more square miles were added to the city of Laredo. Now, about, hey, I like the word about. Let's round. Now, 83.44, let's see. Let's use a compatible number that's close to 44. Now, I know it doesn't fit the normal, like, 5 or more up the score, but we're going to go ahead and up the score here because if I change 83 to 84, that makes it really easy to subtract, correct? So, let's get rid of these guys. And we're going to make this an 84, and we subtract. So, 4 minus 4, boom, 0. 8 minus 4, boom, 4. So, we got about 40 square miles the area of Laredo increased in just that, what was it, 11 years? It was not very much. Yeah, 11 years. So that's pretty cool. Now, here we go, lesson practice. We're already lesson practice. We're only going to do a couple of these because I know you guys are super smart. You don't need me to walk you through every single one. So let's look at A. A says, what is 3/10 minus 15/100? So the whole lesson is adding that 0, right? Sweet. Let's see, who could I call on? Max. Max, what do you think, man? We added that 0, now we're going to subtract. Can I take 5 away from 0? No, we can't, huh? So we got to make that 3 a 2. And we make that 1 a 0. Now help me out, Max. What's 10 minus 5? Can't hear you, man. Got to speak up. I'm all the way in Menifee right now. All right, there we go. Yes, that's 5. And then 2 minus 1, how much, Max? There you go, 1. Bring that decimal straight down, 15/100. All right, and then let's look at C. We have 4.2 minus 0.42. All right, let me hit my insulin pump here real quick. All right, so 4.2, so we are on looking at C right now. So we have 4.2 minus 0.42. Now, notice we got this gap right here. Let's see. Angelina, what are we going to put in that gap right there? Go ahead and say it out loud. What goes in that gap? What was the whole lesson about today, Angelina? Yeah, it's about that 0. Now, can I take 2 away from 0, Angelina? No, I cannot. And I can't take 4 away from 2 either, so I got to borrow from that whole 4 all the way out there in the front. 1 second. Just taking a little insulin. There we go. So we got to borrow from this 4 all the way out here. So that becomes a 3, that becomes a 12, and now we got to borrow from that 12, so it becomes an 11, and there's our 10. Now, Angelina, what's 10 minus 2? We got 10. We take 2 away. Now we only have this many. That's kind of crazy looking, but it was an 8. All right, so that equals 8. And then 11 minus 4 is how much? What is that, Angelina? 11, you subtract 4. There we go, awesome, that's 7. And then we bring that decimal straight down, so it comes down right there. And then 3 minus 0, that's pretty easy, right? Boom, 3. Awesome, doing great. Let's jump to, let's do I. I looks pretty tricky. So if we look at I, we have 1 minus 0.25. Okay, so what do I got to do here? I think we'll go to my class with this one. Let's see, Reagan, help me out on this one. All right, what do I need to add? Remember the whole lesson's about adding what? There you go, zeros. So let's put our decimal in here because there wasn't one to start with, so we don't get lost and do anything crazy, right? So we put our zeros on here, and now we got to borrow, right? Or you could think about it mentally. I think a lot of you guys could do this mentally. If I had $1 and I take away 25 cents, what am I going to have left? I think you already know, but I'm going to go ahead and work it out anyways. So we borrow from the 1, this becomes a 10, but we got to borrow from that 10, right? Right, Reagan? So there's our 9, and there's another 10, so we got a little 10 right there. So Reagan, what's 10 minus 5? So if I got 10, I take away 5, voila! We got 5 left, huh? And then, Reagan, if I got 9 and I take 2 away, what's that equal? Go ahead, yell it out. I hope you've been doing some cooking, Reagan, making all kinds of brownies and cupcakes and stuff. All right, but maybe when we come back to school, I'm gonna have to get some of those. All right, so what's 9 minus 2? 9 and I take away 2 equals how much, Reagan? Awesome, 0.75. Now, let's check out L. L's one of those other kinds of questions where it's a word problem and we got to do a little bit of rounding to try to figure it out. So let's do it. Let's go for it. So problem L. Here we go. So we got L. It says the land area of Long Beach, California is 50.4 square miles. So we got 50.4 square miles. And it says the land area of Jersey City, New Jersey is 14.9 square miles. So we got 14.9. Awesome. And it says about, that's telling us we want to estimate, about how much greater is the land area of Long Beach. Explain why your estimate is reasonable. Okay, so let's go ahead. Let's get rid of the 4. So we just have 50, right? Now, 14.9 is very close to a number. I'm going to show you how close. 15, right? It was 1/10 away. So we're going to go with 15. Now, let's subtract these guys. 50 minus 15, that becomes a 4, right? Because I can't take 5 away from 0, so I got to borrow so I can get a 10. Now, 10 minus 5 equals 15, or 5. That equals 5. And then 4 minus 1 equals 3. So, it's about 35 square miles. We go miles squared. Larger than Jersey City. So, to explain it, all you do is say what we did. We rounded 50.4 down to 50. We rounded 14.9 up to 15. Easy peasy, right? Sweet. Let's look at a couple problems from the math homework. All right, so I'm going to help you guys out with some of these problems. And we'll try to make sure we're getting our math right. I've gotten a couple questions in the Google Classroom, like, hey, Mr. Poole, I don't know how to do number 7. I don't know how to do number 13. So that's great. Keep doing that if you have questions. Let's look at number 2. I want to do number 2 because I know sometimes when we're working with problems, let's see, I think it was like 2 slices out of 6. Let's reduce that fraction to start, right? So I'm going to reduce both by 2, and that's going to give us 1/3. Now, 1/3 is one of those fractions that's kind of tricky to turn into a percentage. Now, we can think of it like this. 1/3 of 100%. So we just have to divide 3 into 100. So 100% divided by 3. 3 goes into 10 how many times, y'all? Someone yell it out. I heard you. 3. So that's 9, and then here comes that 10 again, because we dropped that 0. 3 goes into 10, 3 times again. Now, what do we have as our remainder? 10 minus 9, 1. So, remember the 1 goes on top, and the number we divided by goes on the bottom, and we gotta label it percent. So 33 and 1/3%. I know we've done that one before, but I know that's one of those problems that gets a little tricky sometimes. So, let's look at a couple more problems. I wanted to help you guys out with number 6. Check out number 6 real quick. The thing with number 6 is it's telling us that 10 times n equals 100. So, obviously, what do you think n is going to equal? So, go ahead and write that down on your piece of paper. And then what they want us to do is take whatever that number was and then square it. And then they want what that equals. I'm not going to write it up there because I know you guys can figure it out. I just wanted to help you understand this part first. All right, and let's look. Number 8. It says a door was 6 feet 10 inches tall and 2 feet 11 inches wide. Estimate the area, length times width, right? Area of one side of the door. Now, to estimate, they want us to round those numbers. So 6 feet 10 inches, I'm going to round to what? 7, right? And then let's see, this was problem 8. So they're going to round that up to 7 feet. And then 2 feet 11 inches, that's really close to 3 feet, isn't it? So we're going to round that guy to 3 feet. And then don't forget to label it feet squared when you get your answer there. Let's see, number 10, put a 0 on that. If you can't remember how to add zeros without changing the value, look back to lesson 91. I promise you, you will find it. I think it's example number 2. Example number 2 in lesson 91 will show you exactly how to do number 10. Now, number 11, I was going to do one of those for you. I'm just going to do A, so 11A. So we have 4 and 2/3. So if we look at 2/3, is that fraction more than a half or less than a half? Yeah, it's more than a half, right? If I had 2/3 of a pizza, ooh, pizza sounds good. If I have 2/3, that's bigger than half, right? So we're going to up the score on that guy, and that 4 and 2/3 will become a 5. Hopefully we're getting that. Sweet. If you look at the next page, page 695, let's look at number 24A. 24A. 24's got that table where it's got every gallon, like gallon 1, gallon 2, gallon 3. And then notice how much it increases per gallon. 1 gallon is 128 ounces, then it goes to 2 gallons, which is 256 ounces. So let's think about a rule. Let's say I gave you 6 gallons, how would you solve for how many ounces that would be? So if I was trying to solve that, I'd say, ooh, if I know the number of gallons, let's see, this is number 24, and this is A. So if I know the number of gallons, I need to multiply the number of gallons times what? Who knows it? Who knows it? Come on. 1 gallon was how many ounces? 128. All right, so we need to multiply times 128 to find out any number of ounces. So for B, do this. Do this for B, but you're going to multiply times 8 gallons. So B is going to be 128 ounces times 8 gallons. Good? Rock and roll. I'm going to let you guys work that one out. 26, look at that pattern. From 3 to 4, how much did it increase? 1. Okay, so let's look at the next pattern. From 4 to 7, how much did it increase? 3. Awesome. And then from 7 to 12, how many did it increase? 5. And then from 12 to 19, how many did it increase? 7. So notice how it's increasing each time. So it went up by 1, then it went up by 3, then it went up by 5, then it went up by 7, and then it went up by, okay, keep doing the same thing. Tell me those next 3 terms. And then, 28. I'm going to help you guys 28. Last problem I'm going to help you with for tonight, or for today. 28. We have 600 million. Did I say that right? Yes, all right, sweet. So we got one more zero. But remember, they want it in expanded notation. So you're going to go 2 times 10 to the what power? So we're going to put a little exponent. Count how many spaces there are to the right of the number 2. Count all those spaces. That's the number you're going to put right up there next to your 10. And then we got to add that to 6 times 10 to. All right, so then we got to look at how many spaces are to the right of the 6. So that's going to be the number you put up there for your exponent above that 10 right there. All right, hope you guys enjoyed your math today, and I will check back with you tomorrow for lesson 94. All right, and then actually the week after Easter, you guys are going to have your first math test in the Google Classroom. So, hope you guys enjoy and have a good day.